Howdy, AP PreCal. It is Ms. Kosh. In this video, I wanted to talk about average rate of change and the FRQ on the AP PreCal exam. So I have a few different, this is FRQ 2. This is one that I wrote. I think this is a second one that I wrote. And the third one that I wrote. And one that Mr. Passwater wrote. And so, and those are FRQ 2s. And then I also, there's a Passwater one, I think, FRQ 2. Oh, and another Passwater FRQ. We'll see how many of these I do. Oh, a lot of Passwater FRQ2s that I pulled in. I looked at this yesterday and then decided to make the video today. Okay, and then I also want to look at FRQ3. So here's just a few different examples. And actually, with these, I cropped out just the scenario because what I want to just focus in on this video is talking about all things average rate of change. So what I would suggest that you do as you start, I mean, you could write this at any point, but I have been drawing this little table, or kind of a table, where we talk about the output values of the function, and then we compare it to the average rate of change. Okay, so now your output values can be positive or negative, and that just tells you whether you're sitting above or below the x-axis. It tells you nothing about your average rate of change. If your output values are increasing or decreasing, that will tell you something about the average rate of change. When your output values are increasing, your average rate of change is positive. When your output values are decreasing, your average rate of change is negative. Okay, so what we're looking at so far, what we've talked about is we've got a graph. It's going to go above or below the x-axis, something like that. We can be positive here and here. We can be negative here and here. Okay, that tells us about the output values. That tells us nothing about the average rate of change. We can talk about the graph is increasing. So notice the graph is increasing through here and here. And our average rate of change on those, and pick any 2 points on that interval, and our average rate of change will be positive. Likewise, we would be decreasing as we go, something like that. Okay, the other thing we want to talk about is what happens when the concavity of our output values. The concavity they can be concave up or they can be concave down. Okay. The average rate of change when the graph is concave up, the average rate of change will be increasing. When it's concave down, the average rate of change will be decreasing. So if we look at this graph, what we're saying here, we're concave up something on this interval. And so our average rate of change on this side right here, we start with a negative average rate of change, but it becomes less negative. And then right here, we'd have an average rate of change that gets to 0. And then on the other side, we have positive average rates of change. And so the average rate of change goes from negative to less negative, which means it's increasing. It goes through 0 and it goes to positive values. So the average rate of change is increasing when we're concave up. Likewise, or on the other side, when we are concave down, pretend I went a little too far. So wherever that inflection point is, when we're concave down, our average rate of change is decreasing. We had a pretty steep positive slope, and then it gets less positive, and then we get to a negative slope over there. So what I would suggest, I hit delete too much. What I would suggest you do is when you start seeing any average rate of change problems, write this little table on your scratch paper, okay? And to remind yourself, what are they talking about? Are they talking about output values? Or are they talking about the average rate of change? So is it increasing? When they say, is it increasing or decreasing, what are we talking about? Talking about the average rate of change increasing is different than talking about the output values increasing. So draw this, write this out. I think this will help make things, or come up with something similar that works for you. This just works for me. So now looking at some of these problems, we have, I wrote this one about TikTok, and you'll notice that we've got the ordered pair 4,465.7 million, and then the ordered pair 8,900.7. I think I really did look up those numbers. And so this becomes roughly, I'm not gonna do the previous part of the equation, but this becomes an exponential growth problem, which tells us that it's concave up. Okay, so we're concave up, our graph is increasing over this whole interval. So then when we start to look at the average rate of change questions, interpret the meaning, okay, consider the average. I'm not doing this whole problem. I think I did this last year. I just wanted to emphasize a couple new things this year. Or maybe I've seen it in a different light. Maybe I did this last year and just don't remember. Whatever. Okay, so then they're saying consider the average rate of change from t equals 8 to p, where p is greater than 8. Okay, so in this problem, we had initially said find the average rate of change from 4 to 8. And then now they're saying, okay, so here, this is where t equals 4. This is where t equals 8. And they said somewhere over here, now this is where t equals p. Well, so what's happening? The average rate of change from from 4 to 8 is going to be less than the average rate of change from 8 to p, because the average rate of change is increasing because our graph is concave up. Okay, so the output values were concave up, which told us that the average rate of change was increasing. So as we move in an increasing way, our average rate of change will be growing. Okay, we'll be increasing. Let's see what we said here. Consider the average rate of change. Are these average rates of change less than or greater than the average rate of change from 4 to 8? Okay, when p is bigger than 8, that average rate of change will be greater than the average rate of change from 4 to 8. Okay, I mean, we know that from the concavity. I know they're changing the wording of some of these problems this year, so go check AP Classrooms. They have some videos talking about the new wording for this year. Okay, let me see. Let's look at something that's different. That's another exponential problem, probably an exponential growth, or was it, let's see. Resells, oh, okay, so it's an exponential decay, because notice it's the price of the Tesla is going to go down, something like that, but it's still concave up. So it's going to be increasing. So notice this graph is concave up. I think they did the same thing. So here's 2, here's 6, and then something bigger than that. This is a negative average rate of change. It's pretty steep. This is less steep between those two. So it's a little deceptive because it's concave up. The average rate of change is increasing. We have a less negative slope line, well, slope to the secant line through those 2 points. Okay, what were the other ones that we looked at? More exponential growth. I don't want to look at it. Or exponential growth or decay. I already did both of those. What's this one? Oh, okay, so we have a quadratic right here that they're talking about. Notice I'm not working the whole problem. I'm just talking average rate of change. So here, if I graph this so it's doing something like this. So this is going to be concave down. So when they start talking about the average rate of change can be used to estimate, they're talking about the estimate. Will it be less than the number of cars predicted? Okay, so so hang on, let me back up, I'm sorry. From 5 to 8, so I put 5 at the vertex, but it's probably not. But the 8 is somewhere lower than that. If we keep going, so this average rate of change, since it's, will the estimates using the average rate of change be less than or greater than the number of cars for something greater? Okay, because this is concave down, anything outside over here is going to be above the actual value. So if you use an estimate to find this point right here, and you're outside the interval, it's concave down, the curve will be below that secant line. If we were trying to find an estimate between these points, so something in here, our estimate would actually be on the line below the curve, because we're within that little, so I would, when I encounter these and they ask me about the estimate, I would sketch it out, see what that concavity and what that secant line tell us. Okay, was there another one? You know what, let me jump to the trig ones. Okay, so here, they say describe the rate of change on the interval, they said F to G. So we're looking F to G. Okay, on the first one, is it positive and negative? Okay, on these right here, this is talking about the output values. Okay, so do you remember that little chart that I just wrote? I'm going to write it again just to get it in your head. We have output values and we have the average rate of change. We can be positive or negative, that tells us nothing about the average rate of change. We can be increasing or decreasing, which tells us the average rate of change is positive or negative. We can be concave up or concave down, which tells us that we're increasing or decreasing with our average rate. Our average rate of change is increasing or decreasing. So I think this may be very helpful when you take your AP exam. Okay, so this is talking about the output values. Notice I cropped off the top of the problem. I don't know if they're positive or negative. I need more information based on, like, if this were the point, I don't really care about the input value, but if the output value is -5, or whatever, then these, and this is here, we're at something and then 0. Okay, and then we get back up to positive 5. I totally made up numbers. These points would be positive, but these down here would be negative. Okay, so you need more information to decide if, we can't just look at the graph without knowing any numbers for that part. However, we do know the graph is decreasing, so we can already eliminate those two, and we just need more information to know if our output values were positive or negative. Okay, so how is the rate of change changing? Well, from F to G, we are concave down, which tells me that my average rate of change is decreasing. So I think that if you have time to write a nice, clean, concise sentence, that will be better. So we can say, and I would recommend writing it out. The average rate of change, but spell it out, average rate of change, just in case. The average rate of change is decreasing on, maybe write all the word out, on the interval, is that a V? Anyway, I don't teach you spelling. It's always been my weakness. On the interval t since the curve, nope, that's not a curve, is concave down. Something like that would be a good sentence. Okay, let's look at another one. They gave us, once again here, positive increasing. So describe the rate of change on the interval t to t1 to t2. What did they say? T1 to T2. Refer to the graph. The T coordinate is F and G. Oh, that's the same problem. Okay. This one is K to P. So K to P, right here, we don't know if our graph is positive or negative because we didn't label enough, but we know that our curve, so if we do this output, okay, and then average rate of change, we have positive, negative, we have increasing, decreasing, tells us that we're positive, negative. We have concave up, concave down, which tells us increasing, decreasing. Okay, and so this one we know, what do we know for sure? We know that our graph is increasing, we know that we're concave down, which tells us that our average rate is positive but decreasing. Okay, so average rate of the curve is increasing, so we can eliminate those. We can't do more without labeling the points, like I said. And how is the average rate of change? Describe how the rate of change is changing. The average rate of change is decreasing because we're concave down. Okay, hopefully that was helpful. Definitely write this chart. Like, subscribe, comment, and go practice. Good luck to you.